Hello guys, this is our first video on embedded system series. This is gonna be the introduction video. So let us start by introducing embedded systems. Let's break it down. An embedded system is a combination of hardware and software designed to perform a specific task. Unlike your personal computer, which can run multiple programs, an embedded system is usually designed for one particular job. It's like a computer inside a device, but with a narrow focus. At the core of an embedded system is the hardware, usually a microcontroller or a microprocessor. It's the brain of the system. Then there's the software, which is the set of instructions that tells the hardware what to do. Together they form the embedded system. Embedded hardware unit consists of typically some devices which are connected to it, which we will discuss now. The first one primarily being microcontrollers and microprocessors, which we will discuss the difference between these two in upcoming videos. But for now, let's say microcontrollers and microprocessors play an important part in the embedded system. Next comes the memory. As we have all heard about two types of memory, those are RAM and ROM. So ROM is read-only memory. It stores the program code or firmware that doesn't change frequently. In embedded systems, this is where the essential code resides. And also RAM, random access memory. Temporary storage for data and variables during operation, used for dynamic data processing. This is where RAM takes place, is when you define a variable which has to hold a value, but also it is saving this value in real time. Let's say you shut down the program, you could not save it, electricity went out, something happened, the variable will be lost. So you can say it is a kind of a temporary memory, but something if it is saved in you say ROM, the value of the variable or whatever you have saved would be there, will be there, even if the power goes off. Just let's assume you have saved it. Now comes the power supply. We use different kinds of devices and interface them. We also use sensors and actuators, but we will discuss just after it. But we use different types of device which require different types of power supply, like you say a fan and a bulb. A fan will take more power as compared to a bulb, so different kind of power, a higher power is needed. So we basically decide the power supply based on our requirements. And the next thing is sensors, which is used in an embedded system. So what are sensors? Let's say we put this embedded system into a surrounding. Now in order for that embedded system to act or give us the desired output, it needs to take readings from the environment. Let's say we have designed a greenhouse that would monitor let's say humidity and the temperature and everything inside that greenhouse, which needs to be monitored. So we will use different kinds of sensors for that. Let's say we will use a humidity sensor, moisture sensor, soil moisture sensor, and temperature sensors, different kinds of sensor. A very common sensor used is DHT11, which is for temperature and humidity. So let's say this will take the data from the environment and then send this data to our microprocessor and controller, let's say the brain of the embedded system, where the processing will take place, and then the output will be given to the actuator. Now we come to actuators. What actually are actuators? So actuators are nothing but the output device, the end effector. The end effector, let's say I have said that this is the temperature of the room. After reading the sensor, now the device needs to let's say turn on the AC. So a robotic arm will go like this and turn on the AC. So the output here is sending the hand to press a button to turn on the AC, or twisting something or pressing a knob, anything, that kind of thing. That is the output, and some physical device is doing that, is actuator. It is also called end effector. So after that come timers and counters. Now these terms are often confused within themselves, but there is a basic difference between timers and counters. Timer is something which counts the time, like 1 second, 2 second, 3 second, 4 second, 5 second, and so on. But a counter is something that just counts. You can define the interval between two counts, but it is like 1 2 3 4 5 6. It is not counting the time, it is just using its internal clock and just keeping on counting, like 1 2 3 4 5 6 and so on. Now a very important thing, communication interfaces. So communication interfaces could be of two types. You could actually send data over wiring, like connect two devices with wires, or some connections are wireless. Wireless communications are easier known, like Bluetooth, Wi-Fi, Zigbee. If you studied IoT, you would know what a Zigbee is. But let's talk about wired interfaces. Wired interfaces are mostly SPI, I2C, or some people say I2C, and UART. UART is mostly confused with USB, but it is kind of same thing, which we will discuss in some other video, what actually these communication interfaces are, and we will cover these in detail. But for the introduction, let's move on to something else. Now let's say sensor took a data which sensor gives is in analog form. Analog is something like, it can be anything from let's say we have decided that the maximum temperature could be 0 to 25, like this is the range, 0 to 25 degrees Celsius. Now when you take a physical device to sense the temperature, it could be anything. It could be 0.1, it could be 1.1, it could be 2.7, it could be any range, infinite, anything between 0 to 25. So this kind of reading is called analog reading, which can give infinite values within that range. Now computers understand discrete values, like something like 0 1 0 1 0 1. So we need converters. This analog data, as you can see from the graph of analog, is needed to be converted into discrete form so that the computer can understand. Let's say it is converted into digital form, so we need analog to digital converters. And for the same thing, when the output is decided, like you need to twist something this much, then sometimes we need to change this data back, like a computer has given a discrete information. Now this will be converted back into something called analog, and the device will take analog signals as its input and work accordingly. So sometimes we also need D to A converter, DAC converters, digital to analog converters. Now there are general purpose input output pins. Let's say this is an ESP32 cam, not cam, ESP32 dev kit. It has some pins to it. If you see, there are some pins to it. So these pins are GPIO pins. When we connect the sensors or the actuators or other devices, these pins are used. We also give power supply to this module, to this exact chip. With these there are also power supply options here, if you can see. So we use this to also give power supply. There is also ground, and there is plus 5 volt, but it varies according to what we are using. We do not necessarily use ESP32, but actually it is a very great chip. So let's talk further. What are display units? Display units are anything that you see, like which has a screen. It could be OLED, it could be LCD, it could be other type of displays, but yes, basically they are used for displaying information, like what actually is the temperature. You will not open the computer all the time. You can just look at the screen and get the details. So that is why displays unit are used for. And then comes the clock and the crystal oscillator. What is a clock? It tells the time. Okay, so these controllers, these microcontrollers and all, they need to have an internal clock even if the device is shut down, or they need to maintain a counting. So how are they maintaining, how are they giving a delay of 1 second, or how do they know that 5 seconds have passed? The internal clock gives them the timing. And also how do we maintain such a clock? We have a crystal that oscillates. Mostly it is like 12 megahertz. It could be more, it could be less, but most common is 12 megahertz crystal, which keeps on oscillating, and then we use this frequency to decide the time and take the operations related to time using these clocks. And there are two types of architectures used in embedded systems, which are most common. The first one is Harvard architecture, and then the next one is von Neumann architecture. The Harvard architecture offers separate storage and signal buses for instruction and data. This architecture has data storage entirely contained within the CPU, and there is no access to the instruction storage as data. So basically the main difference between these two kind of architectures are that the instruction set and the data whatever data we have given or stored in one, like in the Harvard architecture they are separated, but in von Neumann they are not separated. They are used continually in the registers. There are no separate registers for instruction and data. This is the main difference. So this was the introduction to embedded systems. To get a better glimpse of what we have talked till now, we will come up with a microcontroller named 8051 Intel microcontroller, which we will use to generate examples and also give the real-time coding examples, so that we get a better understanding and not just words. So let's take that for reference for the time being, and in the future of this series we will come up with different types of microcontrollers, but we will start with 8051. Stay tuned for the next video. Thank you so much for watching this.